Hi everyone, today we're going to talk about infinite limits. So in my first example, we're just kind of reviewing from finding last week, doing left and right-handed limits to find out if a limit exists. So now we're going to look at when limits go off to infinity, positive infinity, or if they really do not exist at all. There is no limit in any direction. So the limit we want to look at is we're talking about the function f of x equals 3 times x minus 5 times x plus 1 squared over 2 times x plus 5 times x minus 1 squared. So I have it graphed for us. So we can just look at our graph and find our left and right-handed limits. So as we're looking for the first one, we want the limit as x approaches negative 5 from the left. So we'll mark our negative 5, which is right about here on the graph. And as we're approaching from the left, we can see that negative 5 is getting bigger and bigger and bigger and bigger. It's going to positive infinity. So here we can say that's positive infinity. But then we need to look from the other direction. So as I'm going to negative 5 from the right, so now I'm on this part of the graph here, and I'm coming down, 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 down. These numbers are getting smaller and smaller and smaller, so we know the limit here is negative infinity. Now, from our previous work, we know that a limit only exists if the left-hand limit equals the right-hand limit. So here we have the left hand equals positive infinity, the left hand equals negative infinity, so this limit fails to exist. It does not exist. And what's happening at our graph right here is we're getting what we call a vertical asymptote. Now on this same picture, remember a vertical asymptote is a line that the graph is going to get close to as it goes off to an edge, but it's not going to hit. We can see there's actually something else happening right here when x equals 1. So same thing, to evaluate our limit, we're going to look from the left. The limit as x approaches 1 from the left, that's this part of my graph here. It's going down to negative infinity. And then I'm going to follow it from the right, and as I follow this graph from the right, it's also going down to negative infinity. So in this case, my left-hand limit and my right-hand limit are exactly the same. So this limit we say does exist, and it goes off to negative infinity. So as I approach 1, I still have a vertical asymptote right here, but the limit is actually a negative infinity. The limit exists because from both sides I'm going the same place, and I'm just getting really, really, really small. And so here I have those sketched in just a little bit more. So as long as there is a vertical asymptote, the asymptote will exist whether the limit exists or not. So if either of those limits is positive infinity or negative infinity, I have to have a vertical asymptote. They do not have to be the same. The limit as x approaches a from the right could be positive infinity. The limit as x approaches a from the left can be negative infinity, as in the case at x equals negative 5. I still have a vertical asymptote. For x equals 1, they had the same, so the limit existed at negative infinity, but it was still a vertical asymptote. All right, so when we're looking at a graph, it makes it a lot easier to be able to visualize where those asymptotes are. But what happens if we don't have that graph to look at? Okay, so remember that we're dealing with fractions, and so when we have a fraction a over b, and a and b can't be 0, we could have a problem wherever that denominator is going to be 0. We can't ever divide by 0. So what we have to think about is if the value of a is staying mostly the same value and b is getting closer and closer to 0, what would be happening to the value of a over b? So if I take some number a and I'm dividing it by a smaller and smaller and smaller number, that's how I know it's going off to infinity, right? If I took 100 and I divided it by a really, really, really teeny tiny number, I'm going to get a big number. Right? And it would be a positive big number, okay? Because positive divided by positive is positive. So as long as a is positive, the top is positive, the numerator, the denominator is going to matter, right? Because if I do 100 divided by 0.0001, that's negative, I'm going to get a negative big number. So as that denominator is getting closer and closer to 0, so if that's shrinking to 0 and I have a really big number on top, I'm going to be getting closer to 0 in my denominator. The limit's going to be either infinity or negative infinity if it exists. All right, so let's use that concept to know as we're dividing by a number that gets smaller and smaller to see what happens. So we have f of x equals x plus 3 over x cubed plus x squared. So we want to find all the vertical asymptotes of f of x, and then we're going to work on finding their limits. So remember, vertical asymptotes happen when the denominator would equal 0. So we want to know, when does x cubed plus x squared equal 0? Okay, so to solve this, I'm going to factor out an x squared. I'm left with x plus 1 equals 0. I set each factor equal to 0, so I have x squared equals 0, x plus 1 equals 0. So I have vertical asymptotes when x equals 0 and x equals -1. So there are two problems here. So now I found all my vertical asymptotes. There are 2 of them. So now I know what's happening at those asymptotes. Is there a limit? Is the graph going in the same direction at those spots? Is it going in opposite directions and then there's no limit? All right, so we're trying to figure out what's happening at those asymptotes. So we're going to start with our first asymptote, x equals -1. So to find the limit, I have to look at the left-hand side and the right-hand side. Now remember, our other asymptote is at x equals 0. So as I come in from the right, I'm only looking at the part of the graph between 0 and -1. So let's start with looking at f of -1/2. So -1/2 plus 3 would be 2.5. -1/2 cubed would be -1/8. -1/2 squared would be +1/4. So I'd have 2.5 divided by 1/4. And we know this is going to be a positive number. Now, we're looking right now, since we know it's an asymptote, we know it has to be going to infinity one way or the other. So what we're trying to figure out, is it positive? Is it negative? Did the limits go in the same direction or the opposite directions? Sorry about the barking dog. So we're looking at, is it becoming a big positive number or a really, really tiny negative number? So because my numerator and denominator are both positive, I know this is going to positive infinity. Again, remember, I know it's infinity because it's an asymptote. All right, so then I want to look at the limit as x approaches -1 from the left. So let's try -2. All right, this way I don't have to deal with a fraction. So f of -2, -2 plus 3 is +1. -2 cubed is -8. -2 squared is +4. And this is 1 over -4. So now we know this is going to be getting smaller and smaller and smaller. It's going to -infinity. So that tells me my limit does not exist. They didn't both go to positive. They didn't both go to negative. They're going in opposite directions on the graph. So if I were to sketch this, all we know about the graph right now, right, not worrying, that's a complicated graph, is at -1, I have an asymptote. From the right, it's going up. From the right, or from the left, it's going down. They're going in opposite directions. Okay, so let's try to figure out what's happening to the graph as it approaches 0, which is our other asymptote. Okay, so as I approach from the right, I'm going to go with 1. That's a nice number. So f of 1, 1 plus 3 is 4. 1 cubed is 1, 1 squared is 1, 1 plus 1 is 2. So this is a positive number, so I know eventually that's going to positive infinity. If I'm looking as I go to x from the left, and remember I can't go all the way to -1 because we know there's an asymptote there, so I'm going to do my f of -1/2 again. And we remember from last time our f of -1/2 was a positive infinity number. So now I know that my limit as x approaches 0 of f of x has to equal positive infinity because they're both going in the exact same direction. So again, to get our sketch, okay, we had an asymptote at -1. I'm going to put my asymptotes in red because my other asymptote is right here on the axis. It's hard to see. And we said last time from the left at -1 it was going down. We said from the right it's going up. And here we said as I come in from the right it's going up. So this graph has to also be going up somehow here. Okay, so because these are matching, they're going in the same direction, we know the limit exists. So now here I went to Desmos.com, which is a great online graphing calculator to help you see things. And if you just first plugged this into the Desmos app and you looked at it, you only see about this portion, and you don't even realize that there are 2 asymptotes there. So you need to kind of blow this up. And this is showing what we had. So this is counting by 1. So here's my -1. Right here, there's an asymptote going in opposite directions. And then this curve did something kind of weird because right here at x equals 0, the left-hand side, there's that teeny tiny little jag, but it's going up, so it's going to positive infinity. So I can use a graph to help me check that I did something, right? But we want to make sure we can do these concepts algebraically. All right, so we have f of theta equals cosecant theta, but I remember that I can rewrite cosecant as 1 over sine theta. And when sine of theta will equal 0, when theta is equal to 0, when it's equal to pi, when it's equal to 2 pi, when it's equal to any multiple, integer multiple of pi. So in this case, we're looking just right at pi. So what the heck's happening to my graph? Because it's undefined. So we want to see what's happening as we go from the left and from the right. Now with this one, I actually think solving it with a graph is a little bit better, but we need to remember how to graph cosecant. So as we graph, here's pi, here's 2 pi, negative 2 pi. I like to start with sine, so I'm going to do that in yellow since that's not my real graph. Sine starts at 0, goes up to 1, 0, negative 1, 0, negative 1, 0, 1, 0. This is just a sketch, so it's a little bit sloppy, but that's my sketch. So I know I have asymptotes anywhere that's equal to 0 when I'm working with cosecant, because it can't be equal to 0 in the denominator. So we want to know what's happening to the graph as we get there. Well, since cosecant is just 1 divided by sine, right here at 1 it's still going to be 1. At negative 1 it's still going to be negative 1. At 1 it's still going to be 1, and we need to know what's happening. So as this is getting smaller, so right around here we're at 1/2, it's going to jump up to 2. Right here at 3 pi over 4, we're at 2 again. So cosecant looks like this. So cosecant is this blue graph. So here we can see, when we're looking at pi, as I'm going from the right, this is going to negative infinity. As I go from the left, it's going to positive infinity, which tells me that the limit for cosecant as theta equals pi does not exist.